Welcome to qnawire.
Over here, in order to be able to properly solve this report, you actually need your lab information, your observations that you made during the experiments. So, for example, in this case, you need to record the temperature at different times and record the observations. So, in the point in which we're going to see crystals that are going to be in solution, that is going to be the temperature for the freezing point. In this case, I cannot give you the temperature because we don't know the value for the molality. We don't know what is going on with the ice bath. We don't know like anything from the actual experiment, right? So you actually need to perform it during your lab session and look at the different observations, right? So based on your activity, what is the freezing point of sodium chloride and of sucrose? This is going to be the temperature at which crystals appear, and the answer would be the same for both of them in this case. So the temperature is going to change from the sucrose to the sodium chloride, but the observation should be the same one. So whenever you start to look at crystals appearing on the solution, record the temperature, and that would be the freezing point for each of the solutions. Now, explain how you were able to identify the freezing point of both of these solutions, and this is going to be by the by the presence of crystals in the solution. So over here, I think that I wrote it down incorrectly for some reason. I forgot. It should be only one L, right? And next, the freezing point of water is 0 degrees Celsius. Do you think the freezing point increases or decreases when added with the solids? And it is going to decrease because this is going to be the colligated property for change of the freezing point, which is going to be equal to minus I times the molality times the cryoscopic constant for freezing of water. In this case, the value for I for N is going to be equal to 2 in the case of NaCl, and it is going to be equal to 1 in the case of sucrose. This is going to be because NaCl in solution in aqueous medium is going to produce sodium plus Cl minus. So this is the formula that you're going to need to employ. And to calculate the molalities of NaCl, what you're going to do is calculate the delta T of freezing would be equal to minus I molality Kf. So the molality would be equal to minus delta Tf divided by I times Kf. So the value for the change of the freezing temperature is going to be the value coming from your lab report. I is going to be equal to 2, and Kf is going to be the cryoscopic constant of water. In this case, Kf of water is equal to 1.86 degrees Celsius kilogram per mole. And with that, it would be all. Thank you very much and have a good one.